Let's talk about modules from chapter 5 of the Gaddis book. So we're going to run through these points about modules. We're going to talk about what a module is, how to define them. We're going to talk about scoping of variables, local versus global variables. We're going to talk about arguments. How do you pass data into and out of modules? And then we're going to look at some specific Java examples, some specific Java language examples to see how we do this in Java. So first of all, a module should be a familiar concept to you already because we already have a module in every program. So when we create a Java program, we create the class and then we create the public static main. That is a module. So it's simply a group of statements that exist inside the program. When our programs start getting larger, we're going to write multiple modules or multiple functions. We'll use the term module, method, and function pretty much interchangeably. They have somewhat unique meanings, but they are generally used interchangeably by most people at this level of Java development. So there's a couple of reasons we want to use modules. One is that if we're starting to write a lot of code, breaking it up into small callable modules makes it easier to read. So most of our programs have been a couple dozen lines, maybe 15, 18, 20, maybe a little more. But if you start getting into programs that are hundreds of lines or thousands of lines or millions of lines, then you need modules and to break those up. You cannot write a single class with 5,000 lines of code and expect it to work well or be easy to modify. It's also easier to find errors. It's less if your code is broken up into modules, you have less problem with blocks and indentation. It's like paragraphs in a paper. It's just easier to read and easier to read, less prone to errors, and better all around. So here's what modules look like in pseudocode. You simply define the name of the module. We're going to talk about arguments and parameters. Those would go here if you're passing data into the module. The module is going to follow the same input processing output method that our main method does. It's just the module is just going to have its own input process output loop. In most cases, the module will have some kind of input which comes in parameters. Sometimes it doesn't. Sometimes it's going to do its own input by prompting for the user or reading from a file. But the module will still have its same input processing output method. This is how you call a module. So this is the definition of a module. With the module, it doesn't actually do anything until you actually execute it. So in order to actually use the module, you have to call it somehow. And on pseudocode, you would use the call statement like this. In Java, most languages, the word call is omitted, and you just use the name of the method to call it. Naming, we name modules and functions the same way that we name variables. So it's going to be lower camel case in Java. They should be descriptive, and they should be obvious as to what the module is doing based on the name. The definition of a module includes it's going to be the name of the module. In Java, there's going to be some scoping and some data types definitions. So we're declaring a module just like we're declaring a variable, very similarly. But you declare it, you put statements in the middle of it. So this is called the definition, which is where you declare the name and any parameters or arguments that you have, and then you have the body, and then of course there's a termination. In Java, we'll see this done with the curly braces, of course. Here's another example of the modules. So again, these are simply definitions. So this module main, module show message, these are definitions. We see here that the show message is being called. So essentially what this does is essentially all the contents of this show message module are essentially replaceable with this show message execution. This is a very simplistic example. There's only one line. But maybe you had a situation where you want to show the hello world message multiple times in different parts of your program, depending on different types of input. You don't want to necessarily have to write that every time. You want to be able to write that logic a single time and be able to use it. So here's how you do it in flowcharts. We've already had examples using main, using the begin and the end. You simply write modules in the same way, using like you would a main with the begin and the end. If you have parameters or arguments, they would also be here in the definition. And then as well, if you're returning data from a function, it wouldn't be included here in the end. When you call it using the flowchart, you use this symbol, which is I'm not sure what this is called, but it's the rectangle inside a rectangle, I guess. So this is called an execution or a method symbol. So here is kind of the approach. We take a really large program. So you have a problem which is create a contact management app for your user. That's a large problem. So you want to break that down into, okay, what are all the modules going to have? I'm going to have a module that is going to add a contact. I'm going to delete a contact. I'm going to search for contacts. Maybe I want to have a module that does some validation on phone numbers or validation on emails. And so what you really want to do when you write a program is you want to think of all the things that your code is going to need to do, and then you can plan your modules by breaking down the code into small, independent subtasks. Each of those subtasks should be simple and easy to write if you've broken it down far enough. And then you have kind of a main method that just drives the code and runs the flow, giving the user options, and then branching out into different pieces of the code as the user navigates through the features. Sometimes in documentation, we have these hierarchy charts. This just indicating where methods are defined. In some of the IDEs, Visual Studio, some of the JDoodle IDEs, you can get something in your editor that will show you where the methods are defined. It's not exactly a hierarchy chart, but the IDE will actually show you what methods are defined and give you shortcuts to be able to navigate to those. And we'll see that in later examples. Let's talk about scoping of data. So when you define variables, we've defined variables inside our main method. We've also defined variables inside a for loop, inside a while loop. So those variables are scoped based on where they're defined. So when you define a variable inside a method or a module, that variable can only be used inside that module. So it cannot be accessed outside the module. Similarly, if you have the same variable name in the main method and you have a method called getInteger or maybe a method called getLetterGrade, you can use the same variable name in each of those methods, but those are different variables because they're scoped locally to whatever method or module that the variable is defined in. It can only be accessed by that. We've seen other examples where even when you define a variable inside a for loop, that variable is defined just within the context of that for loop. So the scoping of the variable is very important. So you have to make sure that you're defining these in the right way. It is possible to use global variables, and we'll talk about that in just a minute. So here's an example of defining methods. So this is a method called getToAges. We define a variable there named age. This method is only going to exist inside this, and also you cannot define it again. So once it's defined inside this method, you can't define it again. So, but this variable age does not exist in your main method, so you can't go back to main and use the value of this age. And once this method ends, once the execution ends and you get to the last line and you exit the module, the contents of that variable are gone. You can't get it back. So just keep in mind that all these variables and the data have scope for where they live. So here's an example of using the same variable name in different methods. So here we've declared this real variable named number. We've declared it again in showHalf. So even though these are the same variable names, they're two different variables, and they will not interact or interfere with each other in any way. So sometimes you want to pass information into a method. So maybe you have a method that's prompting the user for data, and you want to, maybe you're prompting the user for valid integer input, and you want to be able to have a unique prompt for each one of those. So you want to pass data into that method so that the method can use that information to prompt the user in context of the problem that your wrapper method is using. So we talk about arguments and parameters. So an argument is the data that's being sent. So when you call a module, you send arguments on the call statement. When the method is defined, you define parameters that are defined on the definition of the method that will be where those arguments are received. So arguments are sent, parameters are received. That's the nomenclature and how we talk about it. You can pass multiple arguments and parameters. So if you want to pass 2 or 3 or 5 or 10 pieces of data, you simply put it in a comma delimited parameter list or argument list, and they're passed in the same order that they are defined in the argument list. The data types of the argument and the parameter must match. So if you define a parameter of type int, you must pass an argument of type int. Otherwise, the compiler the compiler will probably catch that, but you will definitely get a runtime error if you have mismatched variable definitions or mismatched argument and parameter definitions. Also, if you define a parameter, generally it is required. So there are occasionally times where we'll see optional parameters defined, but if you define 3 parameters, you're going to need to send 3 arguments. And if you don't do that, you'll get a compile error when you try to compile that program. Here's examples of arguments. We're calling showSum with argument of 12 and 45, 2 integers. Then we're receiving those into the parameters here called num1 and num2. These are variable definitions. They are locally scoped to the method showSum. So these are defined. This is variable definition, just like the declare integer result here. Num1, num2 are variables that are defined when showSum comes into context. And they're locally defined, so they will not be available inside any other method, which means you can use num1 and num2 as the parameter names in other methods if you want to. Variables are passed either by value or by reference. The passing by value means that the variable is copied. So we make a copy of the variable and we pass it into the module. Passing by reference means that we pass a reference to the variable. So technically, if you were to change the variable in the method, then the contents of the variable would change in the calling function. And so in Java, primitive data types are passed by value, and others, depending on the type of data, the data type of the method, some of those could be passed as reference. So it's really just a better, it's a good idea to just not change variables, to not change parameters, the value of a parameter in a method. There are some examples where that is done, but in general, we treat the parameters as immutable and unchangeable, and we do not change the contents of those variables inside the method. So we talked about local variables. We can also define global variables. Global variables are defined outside, they're defined inside the class, but outside any module. So in our code, we've declared the class, we declared the public static main, and then we declare variables inside. So we declare scanner and so forth inside the main method. You can declare some variables outside the main method. So if you declare it at the class level, then those become global variables and they're accessible to all of the modules. Now, when should you do this? The textbook says you should avoid this, and generally you should. There are some examples where you would do this. Complex data structures, external resources. Sometimes you'll see the scanner or the input stream being defined as a global variable. That is useful just because you are using it throughout your code, everywhere in your program. It can sometimes get a little messy to have to pass that reference around as a parameter. But there are times when you want to do this and times when you don't. Complex data structures, maybe you have maybe in the contact app example that we briefly talked about, maybe you want to have your list of contacts as a global variable, as a complex data structure, and all of the methods inside your code are going to use that same data structure. So situations like that, maybe you want to use global variables, but in general, you don't want to use them. You want to use them only in these limited spaces. You don't want to use a global variable like as a counter for an array or for a for loop, something like that. That's bad practice. It's going to get you in trouble. You shouldn't do it. It's also notable that if you have constant values, that those typically would be defined as global variables. So maybe you have a constant value That's the name of an external file that you're reading from. That might be something you would want to define as global variable, because you don't want to have to duplicate the definition of that constant in multiple um, in multiple methods. Okay. All right, let's see some Java examples. Here's the definition of a method in Java. We see it looks very similar to the main. So when we declare a main, we have public static void main. That's the definition of a method. This is the same thing, public static void show message. There's a couple, these terms, public static void, have meaning. So public is the scope of the method. Public means that any piece of code that can see this class is going to be able to use this, is going to be able to use this method. So we can write other classes, compile them together into a single Java application, and then they can use the runtime can use code from any of the classes. So public means that in any other method in your Java program can use this method. You can also declare it as private, which means that only the methods inside the same class can use this method. So in our examples, we're going to declare everything as public, but in our class, mostly public or private can be interchangeable here, but we'll declare things as public. Static is a definition of scoping on the instance creation of the class. So we are creating static console apps in our class, and so we are not creating instances of the class. So when we create an instance, we think of things like creating the instance of a scanner. We do scanner equals new scanner system in. That is creating an instance of a scanner. So in our case, we are not creating instances of our class. The class is being run, and so we don't need to. So we are using the static keyword, which means that we don't have to use the new keyword. We don't have to create an instance of our program. The Java runtime is doing that for us. So when we talk about when you get into talking about creating data classes, we often will create a class which has methods and variables that are used to store data to help our program. And in those cases, we would see the static would be omitted. And in that case, we would need to create instances of the class. Void is the data type of the method. So in this case, void means that the method has no data type. It's not returning any data. The method is running, and then when the method ends, it just ends. There's nothing being returned. We're not going to assign the value or the result of show message to any variable in the calling procedure. So we're going to talk about functions in the next video, and we'll see that when we declare functions, that we'll start using a data type, integer, double, string, Boolean, etc. In this space. So this is the header, the definition of the method. In this case, there are no parameters. The parameter block, the parameter list is empty. And then this is the body. So we see it's defined with curly braces. Everything goes in a block, just like in our class on our main. And then inside the block, we have the body, which does whatever our method is intended to do. Here's how we call it. In Java, we simply put the name of the method, and then we include, if there are arguments, we'll include those. And show message has no parameters, so we would not include any arguments. Here's another example of a definition. This includes a local variable called value. This is being defined and is local to my method. So this variable value will not exist outside of this method. Here's an example of a definition that's using parameters. So display value here is a method, public static void. It has no return type and is expecting one parameter. So we'll need to pass one argument to that, and it's declaring a parameter called named num as of type int. Remember, this is a variable definition. So now num, the variable num, is now scoped locally to our display value method. Here's how we call it. We call display value, and we put an argument here. In this case, we're passing the literal integer 5. We could also pass a variable there. We could pass the result of a function, whatever value, whatever data or data structure we're using to maintain that data. This is an argument 5 passed into the parameter num. Here's an example of multiple parameters. This defines two, num1 and num2, and then we just simply use a comma delimited list to pass the arguments in. Okay, again, pass by value. This is a little simplistic definition. Primitive data types are always passed by value. More complex data types are going to be passed by reference. So just know that you should just not change the value of the argument in most cases. This is definition of a global constant. So notice that we have public static void here defined. We've declared a constant outside of the main method. So this is inside the class, which meaning it's between the open and closed block of the class definition, but it's not within a module. So we see that it's outside the main, outside the method 2, method 3. So this is the definition of a global constant, public static final, type int, name is value, and it's a 10. So this becomes a global constant. This variable value can be used in any method inside this class. You could also define another resource here. Occasionally, we'll define the scanner as a public variable. Again, maybe some complex data structures. You want to be sparing with that, but it is something that we will do. Okay, we'll do some exercises in a subsequent video.